Okay, I think we are live. One quick test just to make sure of that. Yes, indeed. We are live on all platforms. All right. Hello, everyone, and welcome to our Friday stream event. Today, I am going to be demoing a integration between TanStack AI and Golem. So Golem is an open source platform for building and deploying and running agents. And TanStack is a very large TypeScript ecosystem that helps developers very quickly build front-end and back-end applications, and also cross front-end, back-end applications. I recently had the pleasure of getting to know the TanStack ecosystem, and I came away very impressed by how much attention to detail there is in the design of TanStack. A lot of expertise and skill has gone into making this entire ecosystem. And so when I saw that TanStack had come out with a new AI library that was sort of fully TanStack idiomatic and integrated into that ecosystem, I knew I wanted to try and see if I could get TanStack AI running on Golem. So ever since the last release of Golem, we've supported two languages, and those are Rust and then TypeScript. And so it's a natural fit. TanStack AI is TypeScript. Golem supports TypeScript. So I wanted to know, could I get this running on Golem? And it turns out that there were a few hiccups along the way. There were a few things that had to be ironed out. But thanks to the work of Daniel Vygotsky here, my colleague, I think he had fixes within 24 hours. Is that right, Daniel?
Yeah, it was not hard to fix these issues, but it was very useful, your feedback that we figured out what needs to be done to make this library usable with Golem.
Absolutely. So now, no hacks, no polyfills, nothing is required. I'm going to show that to you in a second, but you can natively use TanStack AI on top of Golem. And so what I'm going to do today is I'm going to start from a blank directory and move all the way from a blank directory to some sort of semi-interesting but still toy AI agent that is running on Golem and that uses TanStack AI. And in particular, I'll use, doesn't really matter, I don't think that much, but in particular today, I'm going to use their open AI provider. All right, let's get started by sharing a new window. Let's see. Does that look good, Daniel? Can you see that?
Yeah, we can see that.
All right, fantastic. All right, so empty directory here. And I have already pre-installed Golem, and it comes with Golem CLI, which has a way to start the Golem server. I've already started Golem server. So Golem server is running in the background, but other than that, nothing has been done. So what I'm going to first do is type Golem new, because here I want to build a new application on Golem. And if I don't supply any arguments, it's going to ask me in interactive mode for all the arguments that I need to supply. In this case, it wants an application name. I'm just going to call this one TanStack Chat. It wants a language. We only support 2 right now. I'm going to choose TypeScript. And now it's asking for a filter. So I'm just going to go with the basic counter. There's some more interesting ones here, but I feel the counter one's more than enough. And then it wants a package name. Package names have to be in a certain format. So we call this one TanStack Chat as the component package name. And now we have a choice to either create the application as is or add more components. I don't need more components, so I'm just going to create the application as it is. All right, so it should be created. Let's just go ahead and take a look at the directory structure. So here you can see that Golem has created this from a template. There's a common TS section, which contains common parts of like build process and whatnot that would be common across all of our TypeScript components. And then in components TS, we have a single component here, which is TanStack Chat. And inside there, we have what you would expect from a sort of bare bones, minimal TypeScript project. Inside source, there's a single file called main.ts. I'm going to open that up and let you see what it looks like. Okay, we've got some imports here at the top. And these are all coming from Golem's TypeScript SDK. And then we've got some code here. This is an agent, a counter agent. It's pretty much the simplest, somewhat interesting example of an agent you can do on Golem. And here we have a constructor name for the agent, which I'll talk about in a second. And then we also have a single function here as part of this agent that simply increments this private state value by 1 and then returns the new value as a promise. So before I go too deep into explaining what this does, I think it's probably worth trying to deploy this and make sure there are no problems. Let's go ahead and do that. We'll just go into the right directory here. And we'll do Golem deploy and see what comes up. So it's going through different build steps. No problems so far. It's taking a bit, but should be done momentarily. All right, it's asking me questions. It's actually done some planning here, and it's showing me a diff to help me understand what the impact of deploying this is going to be. I can see here that we've added a new component, and this is old stuff I was playing around with. This is the new stuff. So since the last deployment, there have been some changes. I'm going to go ahead and confirm these are the changes that I want. You can see where the server is running at, environment name, all that stuff. Okay, it is deployed. So my component containing this counter agent is deployed and running on my local Golem server. The next thing I want to do is test it. And to test it, what I'm going to do is run Golem REPL. The REPL command will auto-detect that I'm in a TypeScript project, and it will use the TypeScript REPL, which is exactly what I want. So here, I can see that this component has a single agent called counter agent. And the name of that comes from my code. And this single counter agent has one method, which is called increment. And it's a remote method. And that's because the REPL is actually running outside Golem. It's running outside Golem. And the increment method and the agent itself are running on Golem server, which could be located here, but could be located in the cloud. So in general, it's remote. And that's why it has this weird type signature. But nonetheless, you can see increment does not accept any parameters, and it returns a number. You can see that directly in the type signature there, so it lines up. So what I'm going to do is create a counter agent. How do I do that? Well, I use the constructor here, but I don't use it directly. Instead, I'm going to use a get function, which is available statically in counter agent object. And all I have to supply are the parameters that the constructor requires. So in this case, this constructor requires the name of this particular counter. So I am going to just do let counter equals counter agent.get, and we'll call this maybe trials or yeah, tests. This is the name of this counter. I hit enter, and now this counter is available for my use. What I'm going to do is call its single method, which is increment, and then I get back the return value of this method, which is 1. So how is this working in Golem? Well, it works as follows. First off, this method called get is called get for a very good reason. It has upsert semantics. So what Golem does is it looks to see if there exists a counter agent that has already been created with these constructor parameters. And if there isn't one, then it goes ahead and it creates that agent. And it gives me a handle to that created agent. The next time I run this REPL, if I do the same thing, then actually let me show you that. I'm going to exit here, exit the REPL. I'm going to restart it. I'm going to re-get, and note I say re-get and not recreate, re-get that counter agent. I'm going to call it counter increment again. And you see I got back 2, right? So that method or that function in the counter agent object is called get because it has upsert semantics. If that specific agent does not exist, it will be created. And if it does exist, then I'll get a handle to it. So in all cases, I'm just getting an agent that has those constructor parameters. So Golem, the way Golem thinks about agent identity is that in a distributed cluster that contains, hundreds, thousands, millions of agents, the agent identity derives from the constructor parameters of the agent class. So this gives me a very easy way to sort of partition my state space across a Golem cluster and say, well, I want to be able to look up agents by this particular key, which in my case is a string, but it could be any TypeScript type could appear here that can be serialized to and from the underlying data format that is used by Golem. So it could be virtually any pure data type here. And that becomes the key by which I look up agents. Now, this type of agent that Golem gives you out of the box and without any additional configuration is called a durable agent. And it's called a durable agent because the state is durable. And you just saw this. I exited this and I restarted the REPL. I got that same agent again. I increment it. And of course, I'm seeing the next number in the sequence, which is 3. So this durability survives pretty much everything. I can restart my computer now. I can shut down the server. The server could die. Whatever happens, it doesn't matter. That agent is going to be durable. Its state is going to be there. It's global state, not just the state of this particular agent here, which is this number in this name, but everything else it may have touched. I could have global variables here, and I could be updating them, and that state will persist between different invocations. And what Golem does is it will pull an agent in memory as long as I'm interacting with it, but as soon as I stop interacting with it, then that agent basically gets put in cold storage, and its state is preserved. So the next time I interact with it, it's pulled back into memory and starts consuming memory and CPU, and I'm able to increment or interact with that unmodified. So what this allows me to do is to write business logic or agent logic, in this case, that is unconcerned with persistence. I don't have to care about persistence. I can just store things in memory, and I can rely on them to exist indefinitely. And I don't have to worry about infrastructure cost either if I'm running this in AWS or whatever cloud, because agents that are not being used are pulled off and put in cold storage. So I'm not paying active infrastructure costs beyond just the storage associated with that raw state information. So I get to focus entirely and exclusively on the logic of my application, the logic of my distributed system, the logic of my agentic application, agent workflow, or agents, as I'm doing this in this example. And Golem has to worry about and maintain these durability guarantees. Now, the guarantees actually go beyond just durable state. What do I mean by that? Well, I mean that everything that executes in Golem is executed durably. Sometimes I call this transactional execution, because what it means is if you have a big, gigantic method that does 20 things here, and there's some sort of failure event right in the middle, line 26, then what Golem does is it detects that failure event, and that failure event could be as simple as a developer pushing out new version of your application. It could be a server goes down. It could be CPU catches fire. It doesn't really matter what happens. But if I have some sort of failure event at line 26, then Golem, the bigger Golem cluster, detects that failure event, and it migrates all of the agents that were running on that failed node to new machines and that are healthy. It restores the state of those agents, and they continue exactly where they left off. That is transactional code execution. That's durable execution. And what that means is I don't have to think about or plan for failure. Failure could be happening all the time. I'm not going to see it in the code I write. The only types of failures I have to worry about in the software I write are the failures of like this API. I called this API and the API returned a 400 or whatever it might be. I have to worry about those types of failures. I also have to worry about my failures. If I throw an exception and I don't catch it, okay, well, I'm bringing myself down. But I don't have to worry about infrastructure failures. Server failures, all that stuff goes away. I'm programming almost like on an ideal machine that never goes down and whose memory is as durable as stuff stored in a database. So this is a tremendous simplification to the way we write software. And Golem basically, it gives you superpowers when you go to write distributed applications that are highly reliable and highly scalable by default and transparently without me having to do anything. To get these properties, I don't have to do anything. I just write simple, dumb TypeScript code, and I get all these properties for free. Why do we care about that for agentic applications and agentic workflows? Well, because number one, agentic workflows and agents, they operate over long periods of time. And the longer something operates over, the longer time span something operates over, then more likelihood that something's going to go down, right? There's going to be some sort of problem. And if I don't want to have to think about that, then I need to use durable execution. And Golem has it baked in. You don't have to use any sort of SDK. It's just all the code you write is automatically durably executed. So it's fantastic for these long-running AI workflows and AI agents and whatnot. Also, number two, it's a tremendous simplification for me as a developer or for my coding agent, either one, because I don't have to worry about persistence. There's no database tier and caching tier and all these different tiers that you might have to worry about in sort of legacy architecture. I can just store stuff in memory, like my LLM's context or conversation history, or lots of other in-memory data structures. I just keep them here in memory, and I don't have to worry about that persistence at all. So, and then another benefit is, in large-scale agentic applications, you want to be able to rely upon the behavior of your agents. Like as one agent talks to another and distributes to maybe some tools and whatnot, there's so many points of failures, right? If I have 100 agents all coordinating to solve some really big task, There's just so many points of failure. And a Golem makes sure that you don't have to think about any of that, right? There's exactly once guaranteed semantics. When one agent talks to another, you get exactly once guarantees in the presence of any kind of possible failure you could imagine. So when you have large numbers of agents all coordinating together and using tools and whatnot, you really want these bulletproof guarantees so you can build highly reliable systems that are powered by AI, which is inherently non-deterministic. You don't want to add yet another source of indeterminism, which is things failing all the time and network errors and nodes down and application updates. And you don't want all that stuff, because then how are you going to make a reliable AI system on top of that? The answer is you're not. You're definitely not going to be making a reliable AI system on top of that, right? You've got to make sure that you can control for all sources of indeterminism and all sources of failures as you possibly can. And then you have to do additional measures on top of that to make sure that the AI system you build is reliable and has appropriate guardrails and whatnot. But you're never going to succeed in that ultimate mission unless you've got the infrastructure problems completely solved. And Golem solves them for you, so you don't have to write in any specific way, which helps a lot if you're using coding agents. Why? Because coding agents are not going to be able to easily build and maintain a big, fancy event source system that is capable of being extraordinarily reliable, and it can survive the loss of any node, right? And is never going to do duplicate work and can guarantee exactly once semantics. You're talking hundreds of thousands of lines of code to do that. And a coding agent, at least today's coding agents, are never going to succeed in that mission. But they can generate simple code that stores stuff in memory. And Golem gives you the guarantee that it all works perfectly, flawlessly. All right, so where are we at now? We have this simple counter. We've demonstrated that it works. I talked a bit about constructor parameters. Agents are durable. There's a way to specify that you don't want an agent that's durable, and that would be to use a mode property, and you would set that to ephemeral. And if I were to do this for the counter agent, then every time I called get, I would get a new, actually, it's really every time I invoke on that agent, I get a new ephemeral agent. The state's not durable. So you do have ephemeral agents when you want them. Why would you ever use an ephemeral agent? Well, if you don't need the guarantees that durability provides. Like if you're building a bunch of tools for your agentic system, and those tools are idempotent and they have all these other nice properties, maybe you don't care about making the agent as a whole durable, because it's just going to be used as a tool by another orchestration agent, which you might make durable. So there are use cases. If you don't really need durability, why pay for the extra storage costs? Why pay for all the costs involved? If you don't need it, don't pay for it. You can change your mind very easily just by adding the durability mode to that agent constructor. All right, so what do I want to do here? Well, I want to show you a hello world example for TanStack, TanStack AI. And to do that, I'm just going to make one relatively minor cheat, so to speak. I am going to hint a bit to my coding agent, and I'm going to be using AMP here. I'm going to hint a bit to my coding agent how TanStack AI actually works. Like what are the basic things you need to create a hello world using TanStack AI. So you can see here I've added this agents file, and it basically covers the npm stuff and how you create an adapter, etc. So I don't want my agent to have to spend any time figuring this out, although it can figure it out itself. It's going to have to go into the documentation of TanStack, and it's going to find that it's not up to date, and then it's going to experiment. I've seen this several times play out, so I don't want to see it again, and I want to jump straight into the meat of this live stream today. So that's why I created that agents file, just to make sure that we can have a good, highly focused experience here. And now what I'm going to do is I'm going to ask my coding agent to replace this counter agent by a TanStack AI hello world example running on Golem. And I want to call it, well, I'll just let it figure out what to call it. And I'll see what happens here. So what we want is just like bare bones TanStack AI agent running on top of Golem. All right, so it's figured out that it needs to install the TanStack AI packages, which is great. It needs to update this file that I'm looking at here. And then it needs to make sure that there's an open API key in Golem YAML. And that's because when I go to deploy, we want to make sure that it's been deployed with an open API key. I actually have on my system a system environment variable with open API key, but we need to bundle that up into the application. And there's a way that you can do that. Actually, let me show you the manifest file. This basically shows you, has lots of irrelevant stuff. The only thing we care about right now is this open API key. And this syntax here just means, okay, look in my system environment variable and pull that out at deployment time and embed it here in the environment variable that my TypeScript application will have access to, which is exposed via, nodes process.env. So you can see that here, process.env. So that key has to come from somewhere. I'm just putting it in my Golem YAML file, which defines this Golem application. So it ends up being bundled appropriately into the thing that gets deployed. All right, so let's take a look. These changes are done. Okay. We'll go ahead and build it in a second, but I just want to run through this code and see how it changed. First off, you can see we're importing two things here. We're importing a chat function and a create open API or open AI chat from these two TanStack packages. And this one we're going to use to create an adapter, which we need to feed to the chat function. That's the way TanStack AI is structured. So here I create an adapter using this helper function I imported here. And it's using the 4.0 model, a little older model, but probably cheaper by now. More than sufficient for our demo today. And then it's, of course, feeding through the open API key, which was bundled up into the deployment package, or will be bundled up into the deployment package as soon as I build this thing. The constructor here now has agent name. It's arbitrary what you put in this constructor. This is not a bad choice for purposes of this demo. We'll just give every agent a name, and that way you can have as many agents as you want. This is really, or would be regarded as almost like a conversation ID, right? It's a conversation ID. Every conversation has a different ID, and you want the conversation to be persisted for that specific conversation. You create new conversations with blank, empty conversation histories. All right, so here, there's a single method called query, which takes a user message, and it feeds it to the chat function, which comes from TanStack AI. It propagates this adapter, and it constructs a message history that has a single message in it. And this single message will say, well, the role of this message is user. This is the user speaking. And the content is the user's message. And the system prompt is just going to be a single system prompt here, which is you're a helpful assistant. And we're not going to be streaming the results in this simple example, apparently. So let's build this and see if we can actually use it. All right, so Golem build. We'll check to see if it builds. That is unexpected. Maybe just do a clean and see if that takes care of it. Nope. Get rollup error. Well, that's odd. The beauty of live streaming. I swear, I just tested everything I was going to do in here. All right. Well,
Maybe that package has been just updated, and now we are looking at something that is still not supported by Golem.
uh-oh. Well, that could happen. Let's see. So the common JS plugin, my agent says the common JS plugin is scoped to node modules, but partial JSON uses common JS export pattern that rollups common JS plugin isn't handling well with named exports. Don't necessarily trust that. Ah, okay. So I just did not run npm install from the workspace root, perhaps. Let's see. Nope, that didn't fix it.
There was a new TanStack AI release a day ago, according to npm.js, so maybe try the
Oh no.
previous one. Yeah, so set the version to 0.4.
Well, let's see if this hack fixed it. It fixed it. So what happened here?
You didn't
It
build it yet, or did you? You just created the
I
repo
did.
or
No, I
started the
built it.
repo?
Yeah, I
Okay.
did both. So basically what it's saying is that common JS, the rollup configuration for common JS modules did not include the component specific local node modules directories. And that's why it failed. So what I probably should have done is at the root of this workspace, done npm install there rather than npm install inside this directory. Minor error.
Yeah, that would have worked.
Okay. So now let me go ahead and create this agent. Or get the agent, I should say, and call it single method. And all I'm really testing here is this logic here, which sends this single message to OpenAI, this model here. So I'll just ask, who are you? See what we get back. Oop.
You didn't
Oh,
deploy it, I think.
oh, you're right. Yes, you're right. I built it, but I didn't deploy it. Let's try that again. That looks better. Okay, I am an AI developed to provide information and support. I'm here to help you with any questions or tasks you may have. All right, not a bad start. So we've demonstrated that we can get TanStack AI running on top of Golem without making any changes to either. But our agent here is stateless. What do I mean by that? Well, let me actually ask it. What did I just ask you? Um, you asked, who are you? Well, it knows that. That's interesting. So I must be using a stateful adapter here. I'm actually quite surprised. So what I wanted to use was the stateless chat. Let me just, oh no, that wouldn't change anything. This is definitely, there's no state here. Um, but what I can try to do is delete. It may be accumulating in memory in TanStack AI. And so I might have to force this to be deleted. So I want to list them. And then I want to delete that one. And this looks like an old one. I delete both these agents. Do the REPL again and just verify. Okay, so this time I'm seeing what I expect, which is you asked me to recall your previous question, but since I currently don't have memory or access to past interactions, I can't remember what it was. Feel free to ask again. Okay, so what is happening apparently, and I did not know this about TanStack AI, but when I'm using this specific chat method, it appears to be keeping in memory the history of messages. And you can see that's not persistent. So I just tried to force that agent basically out of memory. And what I really want to do here is I want to maintain full control over the history of conversation that I've had with this agent. Now, I don't know if there's a different method I should be using here or not. But what I will do now is I'm going to introduce a history array, store all messages, and update the query method to use and append to that. So I want to move away from relying on what is probably just a quirk of this specific API I'm using to maintaining the entire history set myself. Let me just inspect this code. And verify it's doing what I would expect. Okay, so we have a history array, which is going to store objects in this form. Every role will be user or assistant, and then we have the actual content of that text message. And then we pass a full conversation history in here. And this is still our system prompt. And then every time we get back a response, we're going to push that response onto our history and we'll return it here. So now what we're doing is we're maintaining a complete history of every message that we sent the AI, as well as every response that the AI provided to us. So with this, we have full control over persistence guarantees of the messages that this agent is keeping track of. And I will leave it as a to-do for me to investigate, which is a stateless method of chatting with an AI through TanStack AI. I don't know that off the top of my head. All right, so let me exit this REPL. I will build, make sure there's no problems. And then I will deploy.
You can even do these things from the REPL, actually. You don't have to exit it every time.
I've not used that. But let me
That's a new
deploy. Golem's changing to that. It's improving too quickly.
Sorry about that.
You don't have to apologize for that. All right. Maybe you can help me, guide me to stay in the REPL this time. Okay, so let's try this again. Well, that's interesting. So we push that on there. Did I? Oh, I didn't do a reset, did I?
You can, yeah, you can do .deploy and -- reset from the REPL.
That's what I want. So this is a thing about Golem is that this agent, you're allowed to have agents that are running on old versions of your code. In fact, that's the default. So I made some changes here, but I didn't delete the old agent. And so maybe in a production scenario, I want this so I can be updating my logic and previous agents with their previous state and previous logic are not affected. Obviously, Golem has a way to update those agents, to force update them, if you will, to run my more recent version of the logic. But there are some sort of caveats that go with that. So Golem does safe by default, which is any existing agent that's running, actively running, we're not going to touch that. It's already been created. We'll leave it with its old state, leave it with its old logic, and only new agents will use your new code and have the new state. But in this particular case, I actually do want a new agent or to update the old agent to the new one. So that looks like it worked. And now I can see I have the same stuff I had before. So let's repeat this test and see if I get a different answer. Who are you? And then I'll ask, what did I just ask you? Okay, so now it's remembering. You asked, who are you? Do you like more information or help with something specific? Okay, how is it remembering? Well, it's remembering because right now, every time the user makes a query of this agent, I'm pushing that query onto this array. And I'm feeding that in every time I use this chat method. Okay, let's just make sure that it's actually persistent. I'll ask how many questions have I asked you, including this one? You've asked 3 questions so far, which is right, because I had 2 prior ones. Okay, so this appears to be working. What now? Well, this agent right now is first off, it's invincible, as we would say in marketing. It's an invincible agent, meaning that it will always be running. It'll always be out there running. Its state will always be there. We don't have to do any persistence. If there's any failures, the agent will recover automatically on a new healthy node. So we've created an invincible agent with durable state. And also, the agent can't be stopped, right? If it's in the middle of orchestrating a very big, complex thing like refactoring or onboarding an employee or doing some other complicated series of steps, if something happens right in the middle, and that something could be infrastructure failure, network failure, server failure, software update, or it could even be it not doing anything. If it doesn't do anything, Golem will put it in cold storage, right? So it could be any of these different things. And no matter what happens, if that happens right in the middle of 2 lines of code, well, I don't have to think about that because Golem will detect that failure event and it will restore the agent with its state, its previous state, and it will continue executing at that exact line of code where the failure event occurred. So that's very powerful. I can now rely on this agent to always exist and to never lose work, right? It's never going to forget. It's never going to lose work. It's never going to do the same work item more than once. We get all of these guarantees without having to do anything. There's just no code for that. This is just ordinary code written in TypeScript. And we get all these guarantees by the Golem runtime for durable execution, durable state, transactional execution, exactly once interaction semantics, etc. What else can I do here? Well, how about I make this a little more interesting by adding tools into this example? So here, TanStack AI has support for tools, and what tools are they're a way of allowing an AI to call and execute code and get back the results and incorporate that into the conversation history. So why would you want to do that? Well, it's great chatting with agents, but at the end of the day, we actually want agents to automate stuff that we would rather not do ourselves. So whether we're automating customer support or employee onboarding or code refactoring or whatever thing it is we're automating, we want the agent to actually be able to do things in the real world, which means we need to give it tools. And TanStack has a really great way of doing that. That has a lot of type safety. So what we're going to do is explore that by adding a new tool. And let's start simple. Let's just add a new tool for like rolling dice and getting a random number. So let's have my agent do this. We're going to add a dice rolling tool to this agent. And we're going to do that using the tool support that is baked into TanStack AI. Okay, so in TanStack AI, you can see we're using tool definition, which is defined in this base package. And tool definition uses this helper function. We have a name of the tool, a description, and then we have to specify, in this case, using Zod schema, what the input to this tool looks like. And the input here is going to be the number of sides on each die and the number of dice to roll. Okay, so a fully generic dice roller that can roll die with any number of sides and can roll any number of dice. And then this tool definition, what it does is it creates a little description for the AI's benefit of how to use this tool. And then when we start using tools with our LLM, there's going to be like a little preamble, a little header section on there that says, okay, AI agent, you have all these different tools. And these different tools have these purposes. And these different tools have these input schemas. So the AI knows that it's able to run any of these tools because the sort of preamble that describes all of these tools and how they work is inserted into the context for the LLM. And then the LLM, as part of its sort of multi-turn strategy to deliver to the user what they want, is going to be able to choose to use one of these tools. And when they choose to use it, it's going to indicate that in the format of the text that it generates. And then the orchestrator, in this case, it could be, in this case, it's TanStack AI, is going to look for that. And it's going to say, oh, the AI has decided to use this tool. So I need to call that tool and embed its results back as another message to the AI so it can keep on making progress. And so there's two parts to a tool. There's the definition, which the LLM needs to understand that if it can use this tool does X, Y, and Z. And if it wants to use this tool, it has to provide this required input. That's the definition. But then there's the flip side, which is the implementation. And you do that in TanStack AI by using the .server. And .server just lets you specify the implementation. It's called .server because obviously it would live on the server. And once I specify .server, I now have this sort of complete roll dice tool that I can supply to the AI. And you do that when you call chat. You specify an array of different tools that the agent can use. And now TanStack AI is paying attention to what the AI wants to do. And if it sees the AI wants to use this tool, it's going to invoke this function here. And it's going to provide the results back to the AI. And then the AI can determine whether or not it wants to continue. And maybe it's a multi-step problem that requires using a lot of tools, or maybe it's done and it can return the result to the user directly. So let's go ahead and test this and see if it works. So I want to do deploy build. And after I build, assuming it works.
Actually, I think the deploy will build automatically as well, but I was obliged to do it.
Should I trust that?
Just
paranoia, paranoia. Looks like it's working. Okay, so now I'm going to do deploy reset. Yes. Okay, so let's try this. Create this agent. And I'll ask, what tools do you have? I have the following tools available: roll dice. So this tool allows me to roll one or more dice with a specified number of sides and return the total. So obviously it knows about its tool because that's part of the context provided to the LLM. And this information here comes from that tool definition. So now I'm going to ask the agent, to roll a single 6-sided die and tell me what the number is. You rolled a 3 on the 6-sided die. Of course, at this point, we don't know if the agent is actually invoking the tool or if it's making stuff up, because that's simpler. So I think what we should do now maybe is switch from the non-streaming API to the streaming API, I think, so we can get more, so we can log some more information and verify that the tool is actually being called. Or actually, Daniel, What's a quick way I could verify this just using the op log?
Yeah, I think you can just write, probably it also works from the REPL, but although I never tried agent oplog or something like that. Let's try.
Okay. Oh,
Okay, I don't know what the name is, but we can use the CLI for now. This is a very new feature. Yes, and you have to provide the agent ID,
right. Which would be
which would be your constructor name with John. TanStack chat. Although I think it's using the kebab case for the constructor name
temporary
for
limitation.
historical reasons.
Yes. This will be changing. Right now you have to use camel case for this.
Yeah, and you missed the oplog
Oh, yeah.
command.
In that order.
Yeah.
All right.
And now we have to look for a random call. It will be a call like this polling and stuff. And actually you can run it again and pass a filter. You don't even need to use grep. We have a built-in search functionality. So I think you just let's type random or something. Then filter random. It's query random. I don't know the names. We have to
Where is David when you need him?
is in the chat. Oh yeah, he already wrote me what the comment was in the REPL, but whatever. So just use the help command so we see what the options are. And it is query, sorry. And it accepts complex through query things as well, but we just write rand or random. Yeah, here it is.
Okay. Well, the agent did not cheat. It looks like it legitimately invoked our tool. But let's just refactor this. What I want to do is refactor this to use stream is true. So we can get the individual chunks back out, which have more information on what the agent is doing. So we'll be able to see if the agent is actually using a tool. And here I'm going to say then build and deploy with reset and test by invoking the agent and asking it to roll a die. Okay, so this looks more complicated. What we're doing here is we're setting response equal to an empty string, and then we're switching on the chunk type, and there's different types of things we're looking for. Tool call start, tool call start, tool call end, and then the text message content. Otherwise, things are more or less the same. If we see this, we'll just keep on appending this to response, so we'll get the full response. So my coding agent has already deployed this. And this is the standard output. So it's already run it using the REPL, or rather using invoke. We can see here that its question was, roll a die for me. And we can see the tool call started, roll dice. Tool call ended, roll dice returned rolls, 2, total 2. That's our tool returning this result. And then stream closed, finished, etc. invocation results in wave format, you roll the 2. All right, so we have something that works and that is using a tool. We're going to make this much more interesting in a second. We're actually going to add maybe more tools as well as the ability for one agent to call another. But before we do, we are going to take a short 5-minute break, and we'll see you momentarily. All right, I am back. Let me share my screen again. And grab a bit more coffee. And then we're going to make this example more interesting. So one of the things that I want to do is add a to-do list for this agent here. So we'll think of this agent as being a sort of personal assistant. And so I can talk to it and I can ask it to roll a dice for me, but maybe I can also ask it to add a to-do. That should be quite simple. Why? Because we can maintain the to-dos here in memory. And we can just write very simple logic to go through them and maintain that list of to-dos in response to what the user is doing. So let me go ahead and describe this. And let's see, how many tools should we have here? Well, we should probably have a tool to add a new to-do, as well as a tool to mark an existing to-do as complete. And then possibly a tool to delete a to-do. So let's look for that. I want to add a list of to-dos to the agent state, as well as tools to do the following. We want to add a new uncompleted to-do. We want to, and it's going to get its own ID. And then we want to be able to mark an existing to-do completed. We want to be able to delete an existing to-do by ID. And finally, we need a way to list all to-dos, including their IDs. So we need these 4 things: list all the to-dos so the agent knows what's there, delete existing to-do by ID, mark an existing to-do as complete by its ID, and then add a new one. And then I'll say that it should automatically. I don't want the user to have to specify a to-do ID. So let's just try this prompt and see what we get back from my coding agent. If it's not exactly what I'm looking for, I can always modify it. So yeah, we've been looking for a to-do type and a to-do schema. Okay, so here you'll notice that I actually want my to-dos or my tools to capture over the state of this agent. I have this array here of to-dos, and I want my tools to capture over the state of that agent. So to do that, I just basically do that capturing here using these thunks. And this allows me to list the tools in a very simple form here, where some of these tools are going to be capturing over state information inside this agent. What else? So here's my original roll dice, and then here's my family of to-do tools. And actually, I don't like the way this is structuring this. It should probably just provide it the whole agent state, but it doesn't matter. You can see here, I've got one to add a to-do, one to complete a to-do, one to delete a to-do, and one to list to-dos. So in a future version of Golem, we're going to make all of these methods tools. Basically, any method inside your agent here will automatically be a tool, which will provide a much more idiomatic way to structure this. But it will require a little bit of glue between the Golem stuff, Golem TypeScript SDK, and then your AI provider of choice. Nonetheless, this works for now, and it's just using the off-the-shelf TanStack AI SDK, which many people are already familiar with. Okay, we've got our schemas for all this stuff, and apparently it's supposedly already working. Let's see. Let me actually test that for myself. So I don't know. What ID it used test. Okay. So let's see dot agent list.
It's agent list in a camel case. And I think you can use tab competition as well.
Dot list agents.
Oh.
Is it? No.
Mm.
Agent list.
Agent list, yeah.
I see. Okay, so there is that existing agent there. So let me just get that one. Oh, yeah, of course. And now, what should we test? Let's ask it to tell us our to-dos. What are my to-dos? Here's my current to-do list. Buy milk, walk the dog, write tests. Okay, nice. And let me ask it to, I just bought milk. Complete my to-do. You can see the LLM is responding back with my list, and I've bought milk. So that's transitioned from, you can see the state here is, where is to do? Here. The Boolean state here has transitioned from false to true. Okay, that's working. And what else? I'm going to delete my to-do writing tests because I don't like writing tests. And it's gone. So in order to do that, the LLM would have had to do a multi-step process because it would have had to see what my to-dos are, including their IDs, by the way. In fact, let me see if I can get it to leak information on the IDs. ID 1, ID 2. Okay, great. So this is just a simple counter here. All right, well, I have now a durable agent that can keep track of my to-dos and that can manage that to-do list. It can also roll dice, etc. Which demonstrates, I think, a tool usage sufficiently. But what I would like to demonstrate now is actually one agent talking to another. And I will think about it like this. So let's say we're all at we're building a agent for use inside a company, or maybe use inside a family, like whatever, something like that. Maybe we'll use the family example, right? We're building this platform and everyone gets a personal assistant. Everyone inside our family gets a personal assistant. And this is the personal assistant here. We're building it. It can do things like manage to-dos, but we might have a use case for me adding a to-do to my son's to-do list, right? I want to say, well, you need to take out the trash. Take out the trash, right? That would be a to-do I would want to add to his list potentially. So you can see a use case here for, despite the fact that everyone in our family has its own agent, its own conversation history, etc., we still might want one agent to be able to talk to another. And so let's build out that functionality now, which would be, I'm trying to think of the best way to do this. I think the best way to do this, it's obviously going to involve, in Golem terminology, something called agent-to-agent communication. In Golem, you can actually call other agents. Let me just show you what that looks like. So I can do something like TanStack chat.get, and I'll get the agent for Sarah, and then here I have all of the same methods that I have on this agent. So I have test, which is the one I'm writing now, and I have a query. And so this is actually an RPC call. It's actually an RPC call to wherever that Sarah agent lives in our distributed Golem cluster. And every method, or rather, this is not an RPC call. This, I think, is just basically metadata. But this right here is an RPC call. And wherever this particular agent lives, where the agent is identified by these constructor parameters, that is where this message will be routed to. So I'm calling the query function here, and I'm providing the string input. You can see all of this is strongly statically typed. So agent to agent communication in Golem is statically typed. I can see what the types are. I won't be able to make mistakes because the compiler will stop me, which is fantastic. And I also get IDE autocomplete. Obviously, your coding agent doesn't care about that. But if you're poking around in there yourself, then you do care about autocomplete, and you get that right out of the box. And this is also useful for detecting protocol version mismatch errors and other types of things that might arise in a distributed scenario where you have lots of different agents all running potentially different versions of the same software. So that's how it works. And you get a guarantee from Golem that this is exactly once communication, even in the presence of failures. So if the Sarah agent fails midway because the server caught fire, or my whatever node is running my agent fails midway, doesn't matter. I won't see that. So that's why when I call query here, I actually get back a promise of a string. There's no promise of a string and maybe an infrastructure failure error. There's no RPC errors in Golem because RPC cannot fail. It will always succeed. Because if there was some sort of problem, Golem will see that and resolve that, and I don't have to think about that. RPC communication in Golem is guaranteed. And it's guaranteed to happen exactly once. So how do I want to expose this? Well, my idea is to have a tool that sends a query to another agent and expose that to this agent. So I don't know if that's going to work. I haven't tried that, but let's go ahead and try that. Let's add a new tool which allows our agent to query another agent, identified, of course, by the agent's constructor parameters equals agent name. This will allow our tool to talk to another agent, or sorry, our agent, talk to another agent and get back the response using this new tool. Let's see how this goes. I have a feeling it made a mistake. Let's see. I need to reopen that because I made some changes I do not want to keep. All right, so what did it do in here? It has roll dice, it has all the to-do tools, and then create ask agent tool. See, I'm alarmed that it's using this name here because this is not this agent name. Let me just see what the implementation is. Okay, well, this is what I would expect. This tool should take as input the agent name and the message. But why is it using this agent name? Okay, all right, smart. So an agent should not be allowed to talk to itself, right? And the reason is it would be blocking on its own answer. So we're not going to allow that. Otherwise, we're using this RPC. So this gives us that remote agent with the specified name. And we're going to wait on the response and return the response. Okay, so despite the fact that I was very surprised by it feeding the agent name of this agent into the other one it's trying to talk to, nonetheless, it turns out that there's a good reason for that, avoiding deadlocks. All right, so let's go ahead and see what the testing of this looks like. Okay, it didn't test it. That's fine. I'd prefer to test this one myself. Let's see. I guess I don't need to. I probably do need to do something to refresh this, right? To reload this. I'll just exit. I don't know how to reload this. Okay, so when it deployed, it did a reset, which means it deleted my previous agent. So let me go ahead and here's what I'll do. I'll just ask it to do some stuff. Make two agents. For each agent, add a couple to-dos and roll some dice. And now let's see if it's going to do this. All right. It's invoking, doing invoke. Looks good. So Alice has two to-dos, learn Golem and build an AI agent. Bob has write documentation and fix bug 42. And they both roll dice single time, it looks like. So that's perfect. So that means when I do list agents, I should, agent list. I see two of them, Bob and Alice. That's fantastic. So let me do Bob equals TanStack chat Bob. Oops, not yet. And Alice is get Alice. So now I have Bob and Alice. Let me query Bob and say, what are my to-dos? Okay, that's great. And let me query Alice. What are my to-dos? Okay, fantastic. And let's test our agent-to-agent communication. And how we'll do this is we'll ask Bob add a new to-do. I'll say, let me just see what the description of this agent tool is. Delegate a question to another named agent instance and get back its response. I will say ask Alice's agent to, I'm not sure if this will work because of the way that this tool is described. Actually, maybe we'll just fix that problem. Rather than mess around with it, we'll say that this is ask an assistant. So we'll say delegate a question to a named to the assistant slash agent for a particular person and get back its response. And what else? Name of the assistant or /agent to delegate to. I'm going to say request rather than question. So delegate a request to the assistant or agent for a particular person and get back its response. Names are all our names should be canonicalized by lowercasing. I'll just put that on the parameter, actually. I don't need that here. And removing punctuation. Okay, I think that makes sense. Let's go ahead and Daniel, how do we redeploy and update our existing agents? That would be fun to show off.
Yeah, there should be a parameter for deploy to do that. Maybe tab completion will show it if you start with deploy and then start writing something. It should be update update agents or redeploy agents. That I'm not sure which one. Maybe the help will show if you first run it with --help. I mean, dot deploy help, and maybe it gives us a hint. Or maybe I get a hint on Slack in the meantime.
Use your personal --help, David. Updates existing agents with auto or manual update. Okay, so it's update agents.
Yeah, that's the good one. The other one is recreating the same ones, but with the resetted state. So the update agents auto. Just auto, I think, or maybe auto. Did it say automatic? I'm not sure.
I think it did, but let's see.
Okay, sorry, it's automated.
Okay, so what's going to happen here is I don't want to have to recreate the to-dos in our two assistant agents. So I just want to update the logic without changing the state. Because we've not changed the way this is formatted in memory, that should be fine. Let's try it, see what happens. Yes, that's definitely what I want. Okay. So it looks like that succeeded. Let's give it a try. What we want is create these two again and query what are my to-dos. Okay, so we'll ask Alice's assistant to add a new to-do which will be update TypeScript SDK. Again, can we really trust this? Alice's assistant has added the new to-do. Well, let's see. We'll go back and ask, what are my to-dos from Alice's perspective? And it's there. So it's working. So here we have an example of one agent talking to another and getting them to do something with its local state. And then we independently checked and verified that Alice's state was in fact updated, and that's the case. And we could see all that in the agent op log if we wanted, or we could insert more logging messages here and see them in the console. Right now, there's just this stuff being logged. Actually, I'm not even sure. Do we need to run verbose mode to see that? Or is that just not shown in the console currently in the REPL?
It's not shown in the TypeScript REPL currently. It's actually been implemented this afternoon, so you are not having the latest version yet.
I'm half a day late.
But it will be. So the old REPL, which was not TypeScript, was
Yes.
showing all the output between invocations, and that's going to be available as well in the TypeScript mode.
Yes, that's fantastic. All right, so we have a moderately useful agent here that can roll dice, maintain a to-do list, and also talk to other agents and ask them to do stuff. And all of this implemented with less than 200 lines of code, just 160 lines of code. And we have persistent state for our agents, so our agents will never forget. In fact, that's a frequent hang-up that Golem developers encounter is the agents don't go away. They're always there, and they always have the same version and the same state unless you choose to update their version or clear out their state. Golem is, after all, a durable agent platform, so it shouldn't be too surprising that all of this stuff is going to stick around forever. So we get that property for free, our agents never forget. And we also get another property for free, which you don't really see the utility of in this toy-like example, but that is our agents will always will have transactional code execution. When they're in the middle of something, if there's a failure event, then they will continue at the point where the failure event was. And that will be totally transparent to the outside world. And things like Golem, one agent talking to another, have exactly once interaction semantics. If your agent was talking to the outside world, like a Stripe API, and charging a user's credit card, right? If you had an agent that was doing something like that, then that too would be exactly once, even in the presence of failures. And that happens because Golem supports indemnity key headers on outgoing HTTP requests. And Stripe is one among many different APIs out there that has support for idempotency keys. So within Golem, you always have that guarantee of exactly once interaction semantics. Between Golem and an outside service, you have that guarantee as well, exactly once interaction semantics, providing that service supports idempotency keys. And a lot of the important APIs that do serious stuff, like charging a user's credit card, do in fact support idempotency keys. So what does this mean for you as a developer of agentic workflows or AI agents or AI automation? It means that you, or in this case, like my agent did half the coding here, right? I didn't write all this code. I had my agent do this. You or your agent can write very simple, straightforward code that is enterprise grade in the sense that all of the agent's memory is going to be persisted. I don't have to do anything. And it's as reliable as if I sort it in a database. And also, every bit of code here, every time an agent's doing work, it will be executed transactionally, which means I don't have to think about failure scenarios. Finally, the world has an open source, reliable foundation for agentic computing. AI has enough non-determinism. You don't need to add more with the infrastructure stuff. Golem gives you the invincible runtime that will just make sure all your state is automatically durable and all code execution is done transactionally. And that lets you or your coding agent focus on the hard problems which go above that layer. Right? This is pretty powerful stuff. And it's actually quite a pleasant experience using TanStack AI. I think you can see here, this is actually very, very nice. It's beautiful, beautiful stuff. You get strong types when you're implementing these functions that do the tool, whatever the tool is supposed to do. You get strong types, you get validation. These Zod schemas are used to generate the typed inputs that the LLM needs to know about in order to generate data in that format. So you get this sort of out-of-the-box package with TanStack AI that's very useful. It's very simple. It doesn't get in your way. And it actually has support for much more than just OpenAI. It has support for all the major providers, and it also has provider-specific features, which is one of its selling points, is like if you need to use this specific feature that's only available from this model provider, then you can use it. It's there, and the types infer, you get IDE autocomplete. Your agent will know if it's writing code and not compiling that it made a mistake, and it can fix that mistake. So you get all these nice properties from using TanStack AI. And Golem doesn't have any of that stuff. Golem is the runtime, durable runtime, and then the agent scaffolding on top of that. You can use TanStack AI in any way you want. Personally, I had a great experience building this with TanStack AI, and I would definitely recommend it. The one thing that we need to do as sort of maintainers of Golem is make sure we have better support for tools, right? There's a little bit of boilerplate, you can see that. And also Golem knows about the way we implemented the TypeScript SDK. It knows about all of these methods. It knows what the structure is of the input and output types. That's picked up in this agent decorator here. We know what the constructor is. We know what the methods are. So in a future version of Golem, you will automatically get as tools or available for introspection and use as tools all of the methods of the agent itself. So you won't need any of this boilerplate around the schemas and even the descriptions, right? The descriptions are going to come actually from the description of the methods on here. You didn't see that, but there is a description thing that you can use that's imported from Golem. That will be used when building that metadata that's useful for allowing agent methods to be called as tools. So I hope you have enjoyed this live stream. I will be demonstrating how to use Golem, not just with TanStack AI. TanStack AI is great, but obviously there's the Vercel AI SDK, which is the big one in town, so to speak. That's used by a lot of TypeScript developers. But there's also Mastra, and there is langchain.js and various other libraries out there. And I'll be demonstrating how to use Golem, at least with the big ones. So I hope you've enjoyed this, and I hope you give Golem a try. Notice that some of the features that I used here are actually not in the last public released version of Golem. So even though Daniel's going to hate me for saying this, you're going to have to build Golem from source, as well as the Golem TypeScript SDK, if you want to use the latest and greatest, which is what you've seen in this little demo. And that includes the TypeScript REPL, which is really fantastic. Or if you're building Rust Golem applications, you can use the Rust REPL. So both of those are quite nice. Give them a try. Let us know what you think. Golem is open source. I hope you have enjoyed this presentation today. And I will see you